Hello dear students, this is again AQA exam. Okay, so here question number 9, MCQS question number 9. In the circuit shown in the diagram, cell has negligible internal resistance, so that the internal resistance is almost zero. Okay, so the cell has EMF E whose internal resistance is zero, so that the what happened to the reading of both meters, mean the ammeter and the voltmeter, when the resistance R of the external resistance is decreased. Okay, so we need to find either the ammeter reading increases or decreases, and similarly the voltmeter reading increases or decreases. So as the resistance R of the of this external resistance is decreased, as resistance R decreased, definitely the equivalent resistance of whole circuit also decreases. Equivalent resistance or total resistance of circuit decreases, and when the equivalent resistance of the whole circuit decreases, so it means the current I through ammeter, current through ammeter must also decrease and decrease. So as we know that the if R external resistance R decrease, so R is proportional to potentiometer, R is proportional to voltmeter. So if resistance R decreases, the potential drop across R also decreased, so if potential drop across R decreases, so this voltmeter is parallel with the resistor R, so voltmeter potential drop across voltmeter R also decrease. Okay, so first I want to explain why, when the resistance R of this external resistance decreased, why the equivalent resistance of the circuit decrease. In order to explain this, I want imaginary values. For example, the voltmeter reading has, voltmeter has two voltage of resistance of 2 ohm, and the external resistance is also the so suppose that this is 2 ohm, and so for example the external resistance has also resistance of 2 ohm. So just I am exposing these values. So VR is 2 ohm, and external resistance also has a resistance of 2 ohm. Okay, when for example this resistance becomes less, mean the 1 ohm, suppose this external resistance is decreased, that is equal to 1 ohm. So what is the equivalent resistance between these two? So equivalent resistance, because we know that the if we have previous case, we have total potential across voltmeter is 2 ohm, and the resistance across this is also 2 ohm, so the equivalent resistance 2 multiplied 2 divided by 2 plus 2, that we get 4 over 4, that is 1 ohm. Now when the resistance of this circuit, when the resistance of the resistance is 1 ohm for example, then the equivalent resistance 2 into 1 over 2 plus 1, that equal to 2 over 3, that is equal to 0.6 ohm. So it means when the resistance of a resistor become half, mean it's become less, so that the total equivalent resistance also becomes less. You can see that the before that the resistance is 1 ohm, now when we reduce the external resistance to 1 ohm, so it will become 0.6 ohm, so that the external equivalent resistance of this R circuit reduce, this portion equivalent resistance of this portion reduces. So when the equivalent resistance of this portion reduces, so that the current, total current that flowing through the ammeter also decrease, because the total equivalent resistance reduced. So when the current, so the equivalent resistance reduced, so the current through the ammeter also decrease. And the potential drop, because you know that if R decrease, so the potential drop across R decrease. So if potential drop across R decrease, so the potential drop across voltmeter also decreases. So the correct option is reading of ammeter increases and the reading of voltmeter decrease. So B option is the correct one. Okay, thank you.